Yeah. So you guys can see the screen, right?
Yes.
Yeah. Okay, first I'll be almost all questions you have asked. And so okay, let me check the second one. The second one here, what they were telling. So as a figure shown, sorry, as shown in the figure, a solid sphere is rolling without slipping. It collides with an identical sphere at rest elastically. Okay. So then the radius of the sphere is also like m and r they gave. There is no friction between the spheres. Then the net angular impulse about its center is. See, angular impulse means like what, sir? The change in simply angular momentum. Linear impulse means what, sir? Linear impulse is nothing but change in momentum. Angular impulse means what, sir? Change in angular momentum you have to find. And remember, when let's say two bodies are colliding, okay, whatever the like impulse that is applied by body one on two, the same impulse it will be applied by body two on body one. What is the difference? Can you tell? One difference will be there. What is that?
In direction.
Yeah, good. So that's the only difference. Okay, magnitude wise, it will be same. So either you find change in momentum of this or change in momentum of this. Magnitude wise, they will be same. But only thing that will be difference is what, sir? The direction will be different. Okay. So similar way here, when I want to find angular, like angular impulse, I just need to find change in angular momentum. Sir, for what body I need to find? For any body you can find. Okay. So for anything, as I just now I said, the angular impulse will be like what, sir? Same. So now, according to the question that they're told, actually they're telling, see here, this is having v velocity and this is initially at rest. So initially it is rolling, purely rolling, right? That means this will also have an angular velocity which is equal to what? V by r. Correct? No? Because it's purely rolling, so omega must be equal to v by r. Now, as they told, what type of collision it is, sir? Elastic collision, no? So elastic collision means, so you know, when equal masses are there and the collision is elastic, what will happen to linear velocities?
They get
Elastic collision.
interchanged.
Huh?
They get interchanged.
They will be exchanged. Good. So simply that means, so this is the initial situation, final situation, what will happen, sir? See, only linear things I'm changing. Final things, what will happen? So this one, actually this velocity will become 0, but now this will get some velocity v. And so this one, what about this one? This will still have an angular velocity v by r. Now what they're asking, the net angular impulse above the center imparted to the second ball is. So let's say now basically what will happen? So now it hasn't started pure rolling, right? So let's say after some time it will start pure rolling. So after some time it will be started pure rolling means, let me consider that this will get some VCM and then this will get what, sir? This will get some omega. Now, how to get this VCM and omega? Or like simply, no, I can treat this because after pure rolling, this omega will become what? Omega will become VCM by R. Is it clear?
Yes.
This is just after collision, okay? But I'm finding like once the pure rolling has started, what will happen? So once the pure rolling has started, let's say it is VCM, it is having velocity, different velocity, and angular velocity will be what? VCM by R. Now, what I should be doing, sir, from here to here? What I can do means I can conserve angular momentum. Okay. So just like excuse, they're of different size, but they're same balls. Okay. So this is the situation. So then try to understand here. If I apply torque about this one, what is the net torque about the ground point? Can you guys tell? Net torque about ground point. What is the net torque about ground point?
MVR.
It's 0. Okay. It will be 0. Why it is 0? 0 means total three forces will be acting on the object. What are the three forces? Okay, you need to understand all these things. What are the three forces that will be acting? The three forces are friction, mg, and normal force. Understood? Total three forces will be acting on that. So I'm just selecting some random point here. Okay, some random point on the ground. That's a point P. So friction, just now I told you it will be either in like backward or forward, whatever, that doesn't matter because that will pass through this point. So torque due to friction will become how much? 0, because R perpendicular is 0. And next, coming to this normal force and mg, what about torque due to those two, sir? Is the body moving in vertical direction? Not moving, right? So as it is not moving in vertical direction, that means what? What does that mean? Net force must be zero. That means N must be equal to mg. Therefore, the torques due to these two will become equal and net torque about this point will be zero. When net torque is zero, I can conserve what, sir? Angular momentum. That means initial angular momentum equal to what, sir? Final angular momentum. What? So that means what, sir? Initial angular momentum equal to final angular momentum. What is initial angular momentum about this point? MRV. Final angular momentum about that point, sir? You know, no, what is angular momentum for a rolling case? L is nothing but what, sir? M into R bar cross VCM bar plus what? This is because of translation plus what will be there, sir? Due to rotation, ICM omega will be there. This is what, sir? This is because of translation. Translation of what? Center of mass. And this is because of what, sir? Rotation. Rotation about what? See, remember, rolling motion can be treated as what, sir? Means it's just like translation motion of center of mass and its rotation about what, sir? Rotation about center of mass. That is how any rolling can be like viewed as. Okay. Okay, sir. That's fine. Then, if that is the case, so MRV here, no omega is there initially. And finally, MR VCM plus ICM omega. So they told it's solid sphere only, no? Solid sphere or what? Solid sphere. Solid sphere means I is what, sir? 2 by 5 mr square. 2 by 5 mr square into omega. Omega is what, sir? VCM by R. So tell me from here, VCM I can find or not? So what is the VCM I'll be getting from here? Can you guys tell? MR, MR, MR will get cancelled. That means V equal to VCM plus 2 by VCM. How much you'll be getting? 7 by 5 VCM. Okay, 7 by 5 VCM you will be getting. So therefore, VCM equal to how much you got, sir? VCM equal to 5V by 7. So once we get VCM, then tell me, can I get omega or not? Omega is equal to what, sir? VCM by R. So which means 5V by 7R. Once we get omega, what in the question, what they are asking? What were they asking us to find? They're asking us to find like net angular impulse about its center. About its center. Initial angular momentum is what, sir? Zero about center because no rotation. But after that, what is the angular momentum it got, sir? ICM into omega. So what is like L, sir? L equal to ICM into omega. What is ICM? Can you tell? 2 by 5 mr square into 5 by 7, 5V by 7R. So what is the answer you're going to get, sir? Answer 1R will get cancelled, 5 will get cancelled. So 2 by 7 MRV will be the answer. Is it clear?
Yes, sir.
Understood, right?
Yes, sir.
Next. Next which question?
Sixth question.
Third question.
Sir, in this question, I about that linear angular momentum will be 7 by 5 mr square. No?
From where? From where? I about?
When we conserve angular momentum at that state.
When we conserve angular momentum,
There I will be 7 by 5 mr square. No?
why?
Because we are taking from the axis of ground.
No, just now I told, no. See, angular momentum of anything is given by this formula. Sir, what is angular momentum? It's like angular momentum for due to linear motion of center of mass, which can be written as M into R bar plus VCM bar plus because of pure rotation. Rotation will be considered about what, sir? Center of mass. That's why clearly I wrote ICM into omega. Rotation about center of mass. Clear?
Yes, sir.
Why will we take 7 by 5 mr square? No, don't take I about something into omega unless you came like unless you know that that is like what about that point it is purely rolling. So that is like again different thing. So this is the general formula that we have to use for like what's the angular momentum for anything. Just treating like linear motion of center of mass and like rotation about what's the rotation about the center. Clear?
Yes, sir.
Next. See, next sixth question I'm discussing. Sixth here, what they're telling. Minimum and maximum distance of a satellite from Earth are 2R and 4R. Okay. Where the radius is R. And what they're asking, small m is satellite of the Earth. Then see, that means basically when they're talking about minimum and maximum, that means indirectly you need to like understand that they're talking about elliptical orbit only. Sir, elliptical orbit means see here what will happen. So it will be at one of its focus. Minimum distance is given as what, sir? 2R, and maximum distance is given as what? What's the value? Maximum distance 4R. So this is 4R. 2R and 4R. Now what they were telling? So after 2R and 4R, so they're asking us to find angular momentum. Okay. And what else they give? The radio. So now the minimum and maximum distances they gave. Fine. So angular momentum of a satellite about the center. So you guys know angular momentum will remain what, sir? Constant. Okay, that is what Kepler's second law is. dA by dt equal to constant, which is dA by dt L by 2m. Angular momentum remains constant. So actually you guys can find any like angular momentum at any point, and that will be the angular momentum in the entire like what, sir? Orbit. So first they're asking radius of curvature, angular momentum. So all those things they're asking. Okay. First, let me consider this is capital M. Okay. And here, let's say small m mass is rotating. So now you guys can tell like what is the potential energy of the particle at this point? Can you guys tell? Potential energy between two masses. U can be written as minus G m1 m2 by distance between them is 2r. Is that clear? Minus G m1 minus
sir.
G mm by 2r. And you guys know how to write kinetic energy when you know potential energy? You know how to write kinetic energy when you know potential energy? Or else we'll do one thing. Okay. Radius of curvature, what I need to find? The angular momentum only, no? So that means basically I need to find velocity at this instant. mv square by r. So if this is potential energy, so tell me what will be the kinetic energy? So it will be there in modern physics also. Very, very important, no? Relation between kinetic energy, potential energy, and total energy. What's the relation you guys know? Magnitude wise, total energy will be equal to kinetic energy will be equal to half
Half
of
of potential energy.
kinetic energy. This is very, very important. In modern physics also this helps, no? So the same thing in like gravitation or electrostatics, wherever something is doing orbit. Okay. So remember this is a relation for total energy, kinetic energy, and potential energy. Once you know the potential energy, so tell me what will be the kinetic energy from here? Half of that, no? So kinetic energy will be how much? Magnitude wise, Gmm by 4r, which I can equate it to what? Half m, which I can equate it to half m v square. So half mv square is the value, right? So once you get half mv square, just equate these two. Then what is the v value you're getting? V equal to under root of gm by 2r. So once we get the v value, okay, once we get the v value, so what about angular momentum formula? Angular momentum is m into, what is L, sir? M into r perpendicular into v. So r perpendicular in this case is simply 2r. So small m into r perpendicular is 2r into orbital velocity is under root of how much? Gm by 2r. So what will be the answer? Total answer, final answer. If you just take it inside, what you're going to get? 2 Gm small m square r. So this is the value you are going to get. Clear? So first I found the potential energy. From potential energy, I found kinetic energy. And from kinetic energy, what we have found? Velocity. And from velocity, we can find the angular momentum.
Sir, but it option it is 8/3.
No, 1 second. Let me do maximum minimum speeds. Option A is given now. Maximum minimum distance of satellite from the center of the 2R and 4 respectively. What is the radius of the Earth? M is choose. Angular momentum of the Earth is 1 second. V max, V minimum. What are the things they are asking? It's minimum speed, maximum speed. Okay, 1 second, 1 second. My bad. So let us take the elliptical orbit. Elliptical orbit. Here, let us take this as 2r and this is given as 4r. No, so we know if it is closest, the speed will be what? Maximum. So here I am taking it as v min. Let me take this speed as v min. Sorry, it will be maximum. No, v max. And here, let's say the speed will be v min. So how many unknowns we are having? Two unknowns. No, so we are having two unknowns, so we need two equations to find this one. So what are the two equations that I'm going to use is, first equation is angular momentum conservation. So that is here m times 2r into v max will be equal to what, sir? M times 4r into v minimum. Okay. And then here what will happen? So from here you will be getting v max equal to 2 times v minimum. V max equal to 2 times of V minimum. So this is one equation I got. So equation number 1. But we need one more equation, right? So because two variables are there. What is another equation means? Total energy of the satellite will remain constant. Okay, total energy of the satellite will remain constant. So if the total energy of the satellite remains constant, so let us see here what you are going to get. Let's say I call this point as A, this point as B. Energy at A must be equal to energy at B. Sir, what is the energy at A? What is the total energy at A? Kinetic energy will be there as well as potential energy will be there. Kinetic energy is what? Half m V max square plus potential energy will be what, sir? Minus G capital M small m by 2R, which is equal to half m V minimum square. And here what is the potential energy? Minus GMM by how much? 4R. Now, okay, in the question, what they're asking minimum speed only. No, let us find eliminate maximum speed. Sir, how to eliminate maximum speed? V maximum is 2 times of V minimum. Let me substitute here. Then how much you are going to get? Tell me. M by 2 times of this. You will be getting 4 V minimum square, and this V minimum square I'm getting the left side. So minus V minimum square. So which is equal to what is GMM by 2R minus GMM by 4R? GMM by 4R. Now from here, see small m will get cancelled, and this is how many times? 2 times. So therefore from here what will you get, sir? From here I guess you guys can find V minimum. So 3V minimum square will be equal to GM by 2R. GM by 2R. Therefore V minimum equal to how much, sir? V minimum equal to root of GM by 6R is the V minimum. Is it clear? V minimum. Understood, no?
Yes, sir.
Once we get V minimum, now we can find angular momentum. No, just now I told you at the starting, according to Kepler's law, second law, angular momentum at any point is same. Here you find, or here you find, or here anywhere it's same. So let me find angular momentum at this point. Sir, angular momentum at this point is given as what, sir? L is m into r perpendicular is 4r into v minimum. V minimum is this value. What is this value? Root gm by 6r. So let me bring everything inside. Then 16 by, it will go inside 16 by 6 under root of g capital M small m square into r, because one r will be cancelled. So this is how many times? 2, 8. So 8 by 3 g capital M small m square r will be the answer. Clear?
Yes, sir.
Now total energy. How to find total energy? Total energy you can substitute anywhere. No, let's say here, if I substitute here, I'll be getting the total energy. So what is total energy? Half m v minimum square. What is v minimum square we got? Gm by 6r. No, gm by 6r minus gmm by how much you got? Gmm by not 2r. What is that? 4r. Gmm by 4r. So if I take gmm by r common, what is left out, sir? What is left out? 1 by 12 minus 1 by 4. What is the LCM I can take? 12 I can take. 1 minus 3. So minus 2 by 12. Minus 2 by 12 means what? Minus 1 by 6. So answer is minus 1 by 6 gmm by capital R. Is that
Sir,
clear?
yes, sir. Sir, how to find radius of curvature in this question?
Radius of curvature, where you want to find? At minimum distance. Here, no? See, this will be there in kinematics also. Okay, that also I'll just tell now. Sir, how to find means, this is like, first of all, try to think about why this satellite is rotating. This satellite is revolving only because of gravitational force that is given by the Earth. Right? This is because of gravitational force that is given by the Earth. Sir, what is that force at that instant? Can you tell? Force at that instant is gmm by r square. That is g capital M small m by 2r whole square will be equal to mv minimum square by r 2r. So this will be the answer. Sorry, mv square by not 2r. Don't take 2r. R is not the, like, 2r is not radius. That only we need to find. This is the radius of curvature. Let me take it as r naught. This is our radius of curvature. Radius of curvature is like, it will be something like this. You are going to find radius of this one. How to find, sir? Net force towards center is a centripetal force, which will equate it to mv square by r, and you will get the radius of curvature. So this m will get cancelled. So when you just substitute here, you are going to get the answer. See here, if you want, we can just verify. What will you get? Gm by 4r square, which is equal to v minimum square. Just now we found. No, what is that? Gm by 6r into r naught. R naught. So gm will get cancelled. So r naught equal to 4r square by
Sir,
it's
not the V minimum. Should be V maximum.
okay, my bad. Then it will be twice, no? So because here I am finding here, yeah. So it will be V max means twice of that. So twice of that one means 4 you will be getting. Extra what will be there, sir? 4 times of that. So 4 times of that means 4 into 4, 16 by 6. So what will be the answer? 8r by 3 will be the answer. Clear, no?
Yes, sir.
Third question.
So I told here, like one more concept I told, I'll be telling in kinematics. Okay, in kinematics also, they're going to ask very, very standard question. Okay, previous year question is also there based on this. Let's say there is a projectile motion like this. Okay, they're going to ask you radius of curvature at some instant. How to find it? Can anyone tell me how to find the radius of curvature? Let's say at this instant.
First, we have to find the velocity and then resolve gravity perpendicular and along velocity.
Perpendicular to this one and along this one, and this perpendicular thing, whatever that is there, that is our centripetal acceleration. Just equate that g component to what, sir? V square by r, and you are going to get whatever the radius of curvature that is there at this instant. Okay, always whenever you want radius of curvature, you remember centripetal force you are going to get. What is centripetal force, sir? the force which is perpendicular to the velocity. Once you get the centripetal force, that centripetal force you will equate it to mv square by r, because you know the speed, you know the centripetal force, and you will be getting the radius of curvature. Clear, no?
Yes, sir.
Now coming to the third question. See, this is also previous year IIT. They just added like a bit to previous year IIT question. If you just do archive questions, no. In archive questions, they have given L shape. If anyone has solved, you would have seen in archive, no, they gave L-shaped rod, and they asked us to find in equilibrium what will be the angle theta. That's an archive question. Okay, just to like change a bit, what they have done, sir, instead of this, they kept an U-shaped thing. Okay, now they kept a U-shape, and let's say that U-shape, no, first let me draw this. So this is there. Now this got rotated, no? So let's say this got rotated something like this in equilibrium. Okay, this is the fixed point. Now let's say this is our vertical line. So theta. So obviously, so tell me, when this is in equilibrium, what is the net torque about this point? Is not rotating, no, not moving or
Zero.
not rotating. Net torque must be
0.
0. So if for the net torque to be 0, that means whatever the like center of mass of this entire thing is there, remember it should lie for sure on top of this one. Okay, center of mass of this one should lie on top of, okay, so this line, then only, okay, so it will be in equilibrium. So that is like one thing that you can remember. Okay, so one method I'll be telling you, just try. Okay, so just consider this. You just write center of mass coordinate for each one. Tell me center of, like take this as 0, 0. Tell me center of mass coordinate of this one, you can write or not? That one you can write, no, center of mass coordinate.
Yes.
Or else first I'll tell you the lengthy method, then okay, just now I got some idea. Okay, we'll try by that idea, but I don't know, I'm not sure whether we'll be getting it or not. In short, we'll check. The first idea that I'm giving is, already I told you, for the net torque to be 0, center like the weight should be along this line only somewhere, then only net torque will be 0. Center of mass is somewhere over here, then it won't be in equilibrium position, because of that weight, torque will be there and it will be rotated. So this coordinate I can write, sir, how to write, because this is L by 2, and you will be getting this L by 2 cos theta, and this is L by 2 sin theta. Then you can write this coordinate. Similarly, you guys can write, what about this, like this coordinate? Okay, actually it will be lengthy, it's like complete mass. Okay, so if you want, you can write like where this coordinate will be there. Similarly, this coordinate, where it will be there. And only just find what coordinate you are going to find, means which coordinate you will find. Let's say it got A comma B. This got C comma D. This got E comma F. Which coordinate you will find? Tell me. Which coordinate you will find?
A,
Which coordinate? Huh?
A, B.
No. Only X coordinate you will find. Okay. Find the X coordinate and equate it to 0, and you will get the theta. Here everything, no, every point will be in terms of theta only. Sir, Y X coordinate should be 0. It is on this Y axis, no. When it is there on the Y axis, okay, its X coordinate must be what? 0. That means simply you are going to like find the X coordinate of these things. Okay. So obviously these two will be like at this point. Okay. And these two will also be like, one second. So midpoints. So center of mass of these two will be somewhere over here, and X coordinate of this and this must be lying along this line. Clear? Y coordinate we don't know. It can be there any place. Okay?
Sir.
Understood? No? That is one way, like one method, or like one like way of solving it, which will be, I guess, okay, you can solve it, you'll be getting, because every coordinate you can find in terms of A and B. Okay. Sorry, in terms of theta, and you can solve.
Sir,
But
Sir,
sir, how we can say that y-axis is on left or right side of C, comma D?
I didn't understand. That is like which is on C comma D. Don't bother about whether it is right side or left side. Don't bother about where the line is. You just find this coordinate, this center, like center of this rod coordinate, center of this rod coordinate, center of this rod coordinate. And then just find XCM. XCM is what, sir? M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3. So as this is 0, as all the masses are also equal to 0, so then A plus C actually must be equal to E. This is the condition you're going to get. A plus C must be equal to E you will be getting. This is the condition. And the two, like, you know, one thing, like these two should be like, this is not 45, no? No, yeah. So A plus C must be equal to E. So find that coordinates you will be getting, but it will be little lengthy, okay? So that is one way of doing, which is very lengthy. But
sir,
let us,
rather than doing such stuff, we can do that one corner of a U shape. We can take as a origin, and after that,
which one? U shape?
one corner of the U shape, left corner of U shape as origin,
Yeah.
and center of mass of U shape in the coordinate axis.
What? We'll take center of, this is
Origin,
reference, okay? Origin and
center of we can take center of mass of U shape ball in terms of coordinates,
like, yeah, that also you can
and the
do.
slope
Then it will,
slope through 0, L.
yeah, it will be little easy compared to the previous one. If you take this as origin, that will be little easy. Yeah, so you can take this one, then the calculations will even decrease. Okay.
Sir, I have tried this problem through torque method, but my answer is not matching.
No, here why to find torque?
Torque about that point will be 0
It
due
should
to
be
3
0.
rods.
Yeah. Okay. Okay. You just took coordinates. Okay. Like, see,
That
once
L by
first of all
2.
to apply the torque, no, you should know where the center of mass coordinates are there. Then once you find the center of mass coordinates, no, I guess you would have taken this as 45 degrees or something like that. By default, that only we need to find.
No, sir, we can find the perpendicular distance from that axis.
To this one, yeah, for this one you can
So
find. And
mg
for
into
this
that
one,
axis.
this one, for
What's
this one. Yeah, for this one you can find easily. Yeah, correct. About this I
for
can
all
find the torque.
for all we can find, but my answer is not matching.
Why it won't match? For this one, how much it will be? The perpendicular distance for this row, it will be L by 2 sin theta, right?
Yes.
And what about this one? For this one, tell me how you have found.
I have taken that y-axis in left of that coordinate, and then
Don't. What is the perpendicular? How did you found the perpendicular distance? That's what I'm asking.
uh,
I'll find the perpendicular distance. I'll show you. Tell me whether you have taken that or not. If you have taken that, then you should get correct answer. If you haven't taken that, that means you have done wrong. Sir, like what you should take, no, the perpendicular distance. See here. If this is theta, what will be this angle? 90 minus theta. And what will be this angle? Tell me. This angle will be theta again. If this is L by 2 length, this length is how much, sir? L by 2. This length is how much?
L by 2. Yes.
L by 2 cos theta from here to here. But if this length, you know, total length L, that means this length is what? L sin theta. So therefore, the perpendicular distance should be L sin theta minus L by 2 cos theta. Have you taken this distance? Perpendicular distance for this weight? I guess you didn't like, I guess you took some wrong one. This one you understood how I got this perpendicular distance?
Yes.
Have you taken this?
I have taken this from another side.
No, other side you'll get more. No, other side you will be getting this
Well,
plus this.
Yes, it is different, but same concept I have applied for another side.
This side, I guess you would have taken wrong. Now you check, you'll get the right answer.
And
Okay.
I have more confusion about torque, means which are on RHS and LHS, means which are anti-clockwise and clockwise in this.
Okay, you okay. Now I understood. Like you asked me, sir, which side this will go. That's what you're asking, no?
Yes.
You only tell which side it will be going. Now you can easily tell which side it will go. Someone tell. Okay, you have a doubt that okay, which side this one will go. You only tell me right side it should go or left side. Easily you can tell. Think about it. For sure, it should be left side only. If you ask me why, so tell me this is a closer perpendicular distance than this mass or not?
Yes.
Then torque by this one for sure it will be more than this one, no?
Yes.
So for the torque to be zero, this point should be left side or right side.
Left side.
That's it.
Yes.
Clear?
Yes.
Understood, no, everyone?
Yes.
So torque method you can do coordinate as he said, no, I guess by taking this point it will be little lengthy. Taking this point it will be easy, but I think more rather than torque method, sorry, coordinate method, I guess torque method would be very easy, I guess. Yeah, torque method will only be very easy because already I found the perpendicular distance. You guys can find this perpendicular distance also very easily because this length already I know. I'll just find the remaining perpendicular distance. I guess the torque method would be little what easy, I guess. But I got one more method, okay, as idea, but let us check that. I guess that would, if we can get the answer, no, I don't know whether we'll be getting it or not. That just now I got an idea. That would be the easiest one, okay, if we can get the answer. So what is that means? Let's say imagine that we have a full shape. Okay, imagine that we have a full shape. This size like this. Then you guys know it will be the center of mass where it will lie, sir. Center of mass where it will lie. For sure, you guys know it will be there at the center. Correct, no? I guess this way, this is the best way of solving that question. Yeah. So this center it will be there. And obviously, if this is 0, 0, tell me this coordinate you guys know or not. Yes, you guys know this coordinate. It will be the vertical, this height will be of what, sir? Total diagonal will be root 2L. Half of that will be how much, sir? L by root 2. That means this coordinate would be 0, minus L by root 2. Is it clear? This is our actual center of mass. Correct, no? Now, actually from here, what I have done? I have removed this one. Correct? Or else we'll do one thing. Instead of taking this as center of mass, no, let us do better easy thing. I am taking this only as my origin, center of mass. Now, actually, the center of mass of due to this plus all these things, all these rods, it should be at the origin because center of mass, center point itself, I took it as a origin. Now, tell me for this, I know the center of mass or not? For this, I know the center of mass or not? See, very simply, I can just find that. Sir, what will be the coordinate of that one? Coordinate of that one would be, so if this length is L by 2, and if this is obviously 45, right? What will be that 45? So if this is 45, this will be X length will be how much, sir? L by 2 root 2. And Y coordinate will be how much? This is L by 2 root 2, L minus L by 2 root 2. So this is the like coordinate of this one, right? Now, when the center of mass position of this one, okay, this entire thing plus center of mass of this one should so what you can say, yeah, the center of mass of this entire thing and this entire thing, this whatever the one rod is there, it should be at origin. So I'm just taking this as one part and the remaining thing as entirely one part. Let me take center of mass of that coordinate is some x comma y. Center of mass of that coordinate I'm taking it as what? Some x comma y. Okay. If I take that as origin, no, it will be again wrong because I want to find the angle. Let me do one thing. I'll take this as only origin. Then only I can find the angle easily. 0, 0. Why you will understand. When I take that only as origin, once you get this coordinate, no, center of mass coordinate of this part. So you guys tell me the angle is nothing but what, sir? Then simply I can use, let's say tan theta is nothing but what? Center of mass. That y coordinate by x coordinate I can use. So here, what is the concept I'm using? Center of mass of this point. Now, if this is the origin, so I can write this coordinate something. We'll be getting x L by root 2 comma L by root 2. L by root 2 comma. That's it, no? L by 2, not L by 2 root 2 comma L by 2 root 2. So this is my coordinate of this one. Now, center of mass of this plus center of mass of this, whatever the remaining part x comma y coordinate is there, it should be at this point. This point already I know. By that you can find x and y. So once you get x and y, okay. Once you get x and y, let's say that is the coordinate. Then can you find? Yeah, once you get that x and y coordinate, now if I draw the diagram, whatever the diagram is there, earlier diagram, this diagram. One second. This is how the diagram is there, no? Now, because of this, taking this as origin, you guys are able to tell where the center of mass is there, x comma y. Now tell me, can you tell this angle or not? Okay, then you will be getting not that angle, I guess. Yeah, no. The torque method only, it's easy. Okay, I'll check this one. I guess this way also you can do shift in center of mass. Okay. So, but now you can do, but right now I'm not getting like what quick idea. So I'll just solve it and I'll send you. But that way also you can do by doing shift in center of mass. Torque method you can do, coordinate method you can do, shift in center of mass also you can do. Okay. Next question.
Fourth.
Fourth question, two cylinders made up of same material rolling, okay, above. Then the kinetic energy of the smaller cylinder is given as E. Find the kinetic energy of the bigger cylinder. This is simple only, no? Let's say this is the like bigger cylinder is there. Here smaller cylinder is there. They're telling no rolling, right? No rolling means basically, sorry, no slipping. No slipping means basically the velocity of this point and this point must be same. Velocity of this point and this point must be same. So here let me take velocity of this one to be V and omega to be V omega. Okay. So then, and similarly here, let me take the velocity to be what, sir? They're telling no slipping, right? Without slipping with the plank above them. So let me take this as VC V2 omega 2 V1 and let's take this as omega 1. So obviously I know. So here also no slipping at the ground. Okay. And here also no slipping. That means velocity of this point must be equal to velocity of Planck. Velocity of this point must be equal to velocity of Planck. So as velocity of Planck is same. So topmost what I can write V1 plus R omega 1 must be equal to what is radius? 2R omega 1 equal to V2 plus R omega 2. As anyway, I know that bottommost point shouldn't slide. Bottommost point shouldn't slide. So V must be equal to R omega. That means simply what I can write? What I can write? 2V1. Okay, because this is also equal to V1 and this is also equal to V2. 2V1 equal to 2V2. Therefore, V1 equal to V2. Both should have same, okay, same velocity, same center of mass velocity. But what about angular velocity? Angular velocity will be different for both the things, but center of mass velocity will be same. Now they've given that kinetic energy of the smaller ball is E and the bigger ball they're asking. No, see, if the mass of the smaller one is M, can you guys tell me what will be the mass of the bigger one? Because its radius is 2R, no? So same density, same material. volume will become how many times? 4 by 3 pi r cube means 8 times. So if this is m, this will be how much, sir? 8m. Okay, so this will be how much? 8m. So now, so what will be the answer then? So here you can write half mv square and 2 by 5 mr square omega square. R square omega square is what? V square. So you'll be getting 7 by 5. 7 by 5 kinetic, like I am writing total energy of a solid sphere. 7 by 5 mv square is the total energy. Rotation plus translation. Now, just now we got both have what? Both have same velocities, v1 equal to v2. But what about the masses? What about the masses? Mass of this is m, but mass of this is what? 8m. So what will be the answer? If this
8m.
got energy, so what will be the energy of
Sir,
this one? Huh?
they are cylinders of same length. So
Huh?
volume will be pi r square h. 4
Which
times
cylinder?
m will be the answer, no?
Okay, okay. I didn't read the question. If it is spheres, whatever I have done, that is the thing. Understood the concept? No, I want you to understand the concept. If it is
Yes.
cylinders, obviously, like what you have to do, sir. So it is like pi r square, same length they told, pi r square into length. So its radius is double. So this one will become how much mass? 4m mass. And energy, sir, energy, what I should write? Half mv square plus solid cylinders only they gave. What they gave? Nothing is mentioned means solid. So mr square by 2 into omega square. So r square omega square v square. So mv square by 2 plus mv square you will be getting. So same velocity. Mass is how many times? 4 times. So obviously the energy should be what, sir? 4e will be the answer. Clear, no?
Yes.
If it is sphere, then 8e would be the answer. Yeah. Next.
7th question, D option.
7th question.
Option D.
Option D. Acceleration. No, you're telling that 7th option, you got option D. Like what I need to check?
I have doubt in option D.
Sir, please tell all the options. Whole question.
Huh?
Tell the answer of 7th question whole, not a single question.
Answer is given. Solution you're asking
Yeah.
or key? Okay, okay. In an experiment study the rolling of an object on an inclined surface. Uniform solid sphere is released on a rough inclined plane of given inclination theta. Okay. The acceleration of the center A and the force of friction acting F on the sphere are measured for different values of mu. Which of the following graphs? Okay, correctly. So different values of mu they are telling, no? Okay, so are they telling pure rolling? Is released. Uniform solid sphere is released on a rough inclined surface of inclination theta. Okay, so it's just released. So initial velocity will be, let us take it as 0. So initial velocity, let me take it to be 0. Just release. So initial velocity 0. Let's say inclination theta. Then they're asking about acceleration mu, friction mu. 7. So actually initially, okay. So what will happen? So if you draw the free body diagram, so let me charge the pen. If you draw the free body diagram, mg will be there. Okay, mg sin theta and normal force will be there. So mg cos theta will be perpendicular to that. So initially, so let us analyze starting from A to mu. Okay, so initially we'll see what acceleration that is there when mu is 0. When mu is 0, no, there is no friction. Then tell me what will be the acceleration that you will be having. No friction means just it will slide, obviously. So because of mg sin theta will be there. and mg cos theta and n, they'll get cancelled, right? So then, so obviously you're going to get some acceleration initially itself. What is that acceleration? Constant acceleration will be there, no, when no friction is there. Directly, how much it is, how much it will be? G sin theta. So directly you can tell first option is wrong. Clear? First option we can eliminate directly, no? Because when no friction is there, okay, when no friction is there, obviously, like what? Some acceleration will be there, which is translational acceleration, G sin theta. So first option, actually we can directly eliminate. And coming to the second option, friction value, they're telling slowly it will increase, and after for a particular mu, it will be constant. Huh? Yeah. See, actually, when pure rolling will start, when an object is rolling, no, you know that acceleration. Do you know the acceleration? G sin theta by, what is the acceleration of an object when it is purely rolling? G sin theta by
1 plus
1
k square
plus
by r square.
k square by r square, right? So this is the like acceleration that the body should have. Okay. So that means if I just ask initial acceleration, okay, if I just ask you initial acceleration immediately, so this is actually when this is actually when pure rolling start, this will be the acceleration that you're going to get. But initially, no, it will be sliding. Okay. Sliding means, let's say, F will be there. So acceleration, how much I can write? A equal to mg sin theta minus F by mg sin theta minus F by M. So A equal to G sin theta minus F by M. So this is the graph between acceleration and force. So finally it will become constant. So C also you guys can directly eliminate. C you can eliminate, no? Why you can eliminate? So they're telling that initially acceleration is constant, and so slowly initially they'll be slipping. 1 second. If slipping is there, finally acceleration should remain constant. But see, they're telling that acceleration after some friction is decreasing. So C also you can eliminate. So A gone, C gone. Okay. Next, what are left, sir? Simply B and D are left. So option B and option D are left. So acceleration is constant. Okay. So that's fine. Initially, what is the acceleration when mu is 0? G sin theta will be there. Yeah, D can also be D is like ticking correct in all the boxes, no? After some time, acceleration will be constant, fine. Initially need to check. Okay, D will check first. Friction and mu. Huh. So initially friction because slipping is there. In second, because external force is there, acceleration is there, alpha is not there, friction will be developed. So sliding is there. Initially, what friction will be there? Mu value, they are slowly increasing, huh? Hmm. When mu is slowly increased. Actually, I guess they have given the graphs from like pure rolling has started itself. If you just take like that, when mu is 0, no, whatever the acceleration that is there, okay, what is the acceleration that will be there? G sin theta, it will be there, no, when mu is 0. And after that, this value for sure it will be more than 1. Then it should be decreased, right? Actually, this value tell me it will be more than 1 for sure, right? So in what way they should have given so that the graph would be correct? Now can you tell me? Initially, let's say some constant is there. It should have been decreased and remain constant. Then you would have told it is correct. Understood what I am telling?
Yes, sir.
Understood why D is wrong? Because when friction is zero, what is the acceleration? Tell me. G sine theta. And friction is there after pure rolling. What is the friction? What is the acceleration you're going to get? G sine theta by 1 plus k square by r square. So it is decreasing or increasing with friction? Decreasing. Correct? No. But in option D, what they gave? Increasing. So that's wrong. D also. Okay. Like only thing that is left out is what, sir? That only thing that is left out is what? B option. Okay, B option. So basically when friction is there, so beyond some value, no, once you get this acceleration, whatever the frictional force that is required for this, that accelerate, whatever the mu you get. Okay, so tell me whatever the mu you take, this acceleration is fixed or not? This acceleration is fixed or not? If this acceleration is fixed, tell me this friction will be fixed or not? Because what is the acceleration formula? Net A equal to mg sine theta minus F by m. So tell me, when acceleration is fixed, what will happen to the friction? It will be fixed. But initially it will be just like slowly starting. So only option we eliminated A, C, D. Only option that is like verifying, like validating everything is what, sir? B. So that's why B is correct. Actually, we are eliminating. Okay, we have eliminated A, B, C, and only B, A, C, D. Only B is there. So we have just checked. So obviously, when acceleration is increasing, no. So initially friction will increase, but after a particular mu value, okay, as this acceleration will be fixed. Once the acceleration is fixed, obviously friction should also be fixed. Friction should remain constant irrespective of whatever the mu value that you change. Okay.
Yes.
Understood? No? Actually, sometimes no, like we need to like eliminate the things which are wrong. Then also you'll be getting the answer. But also you need to verify why the other one is correct also. Here I told you why, irrespective of mu, why the friction should be fixed means acceleration, you know, when pure rolling started. So once this is constant, then for what is there any mu value in the acceleration? Tell me, no, right? No. So when there is no mu value, that means irrespective of mu value, friction you should get is what, sir? Constant. So that's the only potential option which can be correct is what, sir? B. Okay.
Yes.
Okay. So I'll do one thing. So I'll just send you the solution for this. Okay. You guys can check, and after that also, if you have any doubt, then you can ask me. Okay, because it's like
Sir,
becoming. Huh.
can you take chapter-wise advanced practice session instead of these doubts? Means it will go all concepts, misconception.
That's what I'm planning. No. So I thought today I'll be taking remaining things. Some of you guys ask constraints and that one. And next
Yes,
class
you
I
can
thought.
take this. You can take that now.
Huh? What?
You can take constraint now.
That's what. So now I'll be taking the class. That's what I'm telling. No, I'll be sending you the solutions for this, whatever the questions I send. You try it. Okay. After that also you're unable to understand, then you guys ask me. Okay.
Yes.
So now I'll be discussing the concepts. So some important concepts or like constraints and that type of like questions. Some key concepts, okay, in Newton's laws and friction and everything. And after that, next class I'll be doing current electricity or electrostatics. Which one you want? Electrostatics or current electricity?
Current electricity.
Okay, so we'll do current electricity. So in the next class, that assignment I'll be sending you morning. So like you guys can practice till our next session, and then we'll be doing. Okay. So constraints also I'll do. Okay, before that, so I'll just want to tell you some more important concepts. So let's say M1 mass is there here, or M2 mass and M1 mass, and a force I am applying here. Okay. Now the question that they're asking is, what is the maximum extension that will be there in the spring? The question that they're asking is, what is the maximum extension that will be there in the spring? So can anyone give me idea how to find? Initially the spring is uncompressed, like in natural length. So tell me how to find the maximum extension in the spring. Just tell me, like let's discuss. Like, tell me, like, what are the thoughts that you are having? No need of telling till the final answer. Okay, you just tell me the approach. What way you will be doing
At
when they ask.
maximum extension, the speed of both blocks will be same.
That's the condition that we'll be taking. Yeah, but how? Yeah, with that, how can I get a conclusion? Speed. That's true. At maximum condition, both should have same speed. So how will I use that point? Anyone? Just tell me the ideas only. 1 minute, no, whatever. Let's say this exam you have seen tomorrow's like what advanced paper. You just tell me idea. No need of going till the last step and telling me what is the final answer. What approach? Just tell me like what will you do? Just take the inputs. If it is right, I'll explain. Otherwise, see, like
Energy
imagine
consumption.
that only. Any question I'm giving, imagine this is there in your advanced paper. What idea you'll be getting in mind that you need to tell immediately how to do in the exam. So just tell me ideas only. Like, yeah, what will you
Energy
do?
conservation.
No, finding displacement, taking time into consideration will be very, 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 very lengthy. Okay, see, this is also like one of the standard, like very important models for advanced or like good exams. So I'll be giving two methods for this one. Okay, both are very, very important. So you can find mostly you'll be finding only one, okay, or like one model or like one type of solution in the books. So, but I'll be giving two different solutions, which are like both are like completely different. Okay, and you're going to learn two important concepts here. The first one, no, I'll go and stand on center of mass and I'll solve. I'll go and I'll stand on what, sir? Center of mass. Tell me, can I find center of mass acceleration or not? How much it will be there? F by total mass m1 plus m2. So this is my acceleration of center of mass. Correct? No? What is the acceleration of center of mass, sir? Acceleration of center of mass is simply just imagine this is like one single block. F by m1 plus m2 is my acceleration of center of mass. Now I'm telling that I'm solving the entire question going on to this frame. No, that means tell me the entire system is like so center of mass in accelerated frame or non-accelerated frame. Just now we got an acceleration. So it's an inertial frame or non-inertial frame.
Non-inertial.
So pseudo force I need to add. So pseudo actually it will be going right side. That means pseudo force on this one will be m2 times a center of mass, and this one will be like going pseudo force on this one will be what, sir? This one also right left side because the body is going right side. M1 times ACOM. Now I am standing. Okay, for me, if I am standing on center of mass, for me, what I should tell, sir? Simply M2, M1 will go left side. Okay, so whichever side you're standing, M1 will go one side and M2 will go one side, but I am standing still. I'm just standing there only because I'm solving the question with respect to center of mass. So when maximum extension is there, okay, what should happen? Okay, see here, like how like beautifully we can connect the standard questions. Why I will be asking you to like everyone ask you to solve PYQs means PYQs, okay, are like some standard concepts. So from the standard concepts, no, whenever your basics and standards are so strong, you can connect that to some beautiful questions. Okay. So as I said, this type of solution you might not find in like many books. Okay, it's difficult to find. Okay, because these are the analysis that okay some of us will be doing, okay, just connecting it to like what are the standard concepts that will be there. See, I guess this is a standard question even for mains, everyone knows this, but connecting this to an advanced question or like understanding that this is the concept that we should use here, that is the most important thing. So tell me, when there is a block of mass I'm connected to a spring, okay, connected to a spring. Initially, it is unextend, like it's no extension is there. Can you tell me what is the maximum extension in the spring? Can anyone? It's a standard question, no? I guess maybe some one of you directly you might tell the answer.
2
What is the
mg.
maximum extension? Huh?
2 mg by k.
2 mg by k. So this is standard one, right? Actually, just by using this concept. No, actually this can be done, this question can be done in many ways. They'll be doing, I'll tell only two ways. The other way you told, like taking force equation, time, work, and they can be done in many ways, but it can take half an hour, 1 hour also to like solve in some random methods, or half an hour it might take. Okay, finding time, displacement of this one, displacement of this one, introducing many variables, eliminating, it will be very lengthy. Sir, how you got this as 2 mg by k? Obviously, initially it is net force is not zero. It will extend till where the net force is zero. That means mg will be equal to this kx naught. But will it stop there? Will it stop there? It won't stop there. Why? Because it got some velocity, no? It got some velocity. Because of that velocity, even the it's in equilibrium, it's going to continue. Till what distance it is going to continue? Whatever the displacement here that is there, same displacement will be covered. So kx not equal to mg means here mg by k, here mg by k. So total extension is how much, sir? Total extension is how much? 2 mg by k. Correct, no?
Yes.
Correct. Now, tell me, this is the same situation or not? Whatever the situation I gave, no? Actually, if you just understand, it's the same situation. It's not the same situation I gave. I converted that into that standard situation. Now tell me, now I'm standing. That's like a fixed point. Now tell me M2 into ACM, that is constant or not? It's a constant force, right? See, in one step, no, without even writing anything, I'm writing the acceleration. What is the acceleration? Sorry, X, just now I told you, X max will be equal to, now who is taking this mg role, constant force role, who is taking? Who is taking constant force role?
It's weight.
Pseudo force. Understood, no? Then, what is the answer, sir? 2 times M2 into ACOM by K. This is the answer. One step done. 2M2 by F
So,
by M1 plus,
will you please repeat the concept of pseudo force applied out here?
pseudo force. Yeah, pseudo force. Okay. Pseudo force, actually, whenever any frame is accelerating, you just need to add pseudo force on that particle. Okay.
Yes,
Sir,
sir.
how you should add means how you should add any particle, all the particles that you need to add that pseudo force. Sir, how you should add? First of all, you need to know force means three things you need to know. Remember, force means three things: magnitude, direction, point of application. Three things. Okay. Actually, the third one, no, it will be used only in rotation motion. Other than rotation, it's not that important. First two are like very, very important. But third one is also for understanding rotation and solving some good questions, tough questions. Third point is also important. What are first 2 points? Magnitude, direction, point of application. Sir, what is magnitude, sir? Remember, pseudo force magnitude is mass times acceleration of frame. In whatever the frame that you are sitting, no, that frame's acceleration you have to take. Mass times acceleration of frame. That is the pseudo force magnitude. Direction, remember, opposite to the direction of frame. Force direction is what, sir? Opposite to the direction of frame. And final third point. What is the third point? Point of application. Sir, what is point of application? Center of mass. Point of application is what, sir? Center of mass is my point of application. See here. Now, the center of mass, because force is right side, no, acceleration will also be right side. Acceleration of center of mass actually is on what direction? Right side. But I am going and standing on center of mass now. I am stopping the entire thing. For me, center of mass is at rest means, so it's a pseudo force, right? Non-inertial frame, so I need to add pseudo force. So see here, this mass of that object, pseudo force on what you need to find, that mass you need to take. So that's why on this object, mass of M2 into acceleration of frame. On what frame I am sitting? Center of mass frame. That's why I took acceleration of center of mass. Direction is what, sir? Opposite to the frame. Center of mass is moving right side. That's why force is left side. Clear?
Yes, sir.
And same thing here. Pseudo force on this one is M1 times mass of this body times acceleration of center of mass. Direction is again frame is going right side. That's why pseudo force is left side. Clear?
Yes, sir.
Sir,
Now,
can we
tell
take
me,
two and do M1 ACM by K.
What? 2?
M1 ACM by K.
I didn't understand. No. That
For
side also you can
X.
solve. That side also you can solve, but that side is different. No, force is also involving.
Yes.
Understood? No, force is also involving. No,
Yes. Yes.
these two forces are there. That's different. Even if you solve from that way, also you will get the answer. That I'm giving you as homework. It will be little lengthy, but you will get the answer.
Yes.
Okay. But so why I selected this block means, see, this is the analogy for this block or not? This system, whatever I told you. See, within one step, one line, we got it. Because this is like something like fixed thing. Because now, according to me, like I'm not moving. So for me, now there is a constant force. Any of these things is missing, I cannot use this theorem. When I cannot use this basic concept, even this center of mass is moving, I cannot use. Even let's say this force is not constant, then I cannot use. I'm able to use this concept directly here only because the force is constant and this point is not moving according to my frame, center of mass frame. Clear?
Yes.
Understood? No, everyone.
Yes.
Now the same question I'll tell you one more model. Okay, one more way of solving it, and I'll give you one more beautiful question, like which includes that whatever the concept that I told. Okay, so one more way of solving it. Obviously, it will be little lengthy. Okay, why? Because obviously, like here we are like here very beautifully, like we converted like one standard concept into this one. That's why we got the answer very easily. But actually, how to solve this one means, okay, like one more way. There will be many ways. The first one is the best one that I told, okay, which you cannot find in many books. And this one, let's say acceleration of this one is A1, acceleration of this one, let's say A2. Now I came for the ground frame. Okay, let me come to the ground frame. Let me write here. Let's say force on this one is kx right side, and obviously on this block it will be kx left side, and m1 will be there, f is here. Let's say acceleration of this is a1, acceleration of this is, let's say, a2. So a2 can be written as what, sir? Tell me. A2 can be written as kx by m2. A1 can be written as what, sir? F minus kx by m1. Net force by mass only I'm writing. Is it clear, this step? Now, can I find relative acceleration or not? Acceleration of, let's say, m1 with respect to m2. Okay, or acceleration of 2 with respect to 1. Acceleration of 1 with respect to anything. Acceleration of 1 with respect to 2. If I find a1 minus a2, what is a1 minus a2 you are going to get, sir? A1 minus a2 is f minus kx by m1 minus kx by m2. Is it clear? This is acceleration of 1. This I am calling it as relative acceleration. Okay. So this also it will be like difficult. Okay, like to find many books. Okay. So now try to understand this concept. Like when I asked her like different ideas, one of you told an idea of what, sir? When maximum extension is there, sorry, when maximum extension is there, you told they both should have. Someone told no.
Same speed.
Huh?
Same speed.
That means relative speed is how much?
0.
0, right? So from now onwards, you try to understand like acceleration, velocity of a single block, relative acceleration, relative displacement, relative velocity, you can also take like one parameter. Understood what I'm telling? Let's say for a block, you'll have displacement, acceleration, velocity like that. No. Similar way, you can also consider relative acceleration, relative velocity, relative displacement in the same way. Understood what I'm telling? Just like normal thing, you can also consider these are same. Now, if I want convert this acceleration to velocity, what is acceleration? Is the rate of change of velocity, right? So if I write dv relative by dt, I cannot solve this. Why I cannot solve this? Can anyone tell me? This is also in kinematics, no? Standard questions. Why?
Because it is in terms of x.
In terms of x, no, function is in terms of x, so I cannot integrate. So then you guys know how to write a, no? How to write a? Can anyone tell me? Actually, a can be written as dv by dt, but this I'll multiply it by dx and divide it by dx. Then dx by dt can be written as v. So acceleration can also be written as what, sir? V dv by dx. V dv by dx. Is this fine?
Yes.
Yes.
Now this I'll equate it to f minus kx by m1 minus kx by m2. Now I'll take dx other side and I can integrate or not?
Yes.
Yes.
Correct. What is initial limit of v? Here v means v relative. What is initial limit of v relative, sir? Initial. Both are not moving, no? Relative velocity is how much?
0.
Finally, also both are moving, but both will move with same speed. That means final limit of v is also how much?
0.
How much?
0.
0. So actually, if you take this dx this side and integrate, no, left side you are going to get 0 minus 0. Right side integrate it and keep the limits from where to where? X limits from where to where you have to keep. Come on.
Initial separation to x max.
Not separation. X is not separation. Okay. X is the extension. Kx. What is x, sir? In spring force, F equal to kx. What is x?
Extension.
Extension.
Extension or compression, right? Here x is not the separation between the blocks. Okay. X is not separation. X is the extension actually. So that's why x limits initial extension is how much? 0 until where we are going to taking, sir, x max. So when you solve this, tell me you are going to get x max or not?
Yes, sir.
Is it clear?
Yes.
Understood both the methods? No. This is like one of okay, very important model. Like here we understood one more point. Pseudo force concept we understood. Along with the pseudo force concept, one concept, very important concept we understood, that just like V, A, S, V relative, A relative, S relative between two things also, like same way we can do. Okay. Now I'll give you one beautiful question. So then, okay, then you'll get a complete idea what I'm telling and like why I'm telling this concept is very, very important. See, this is the question. Okay, you guys try solving this question. The question is, actually there is a plank. Okay, let's say plank got some velocity of m, and here on top of this, no, I'm keeping a small block. Initially I thrown with some velocity v naught, and here I gave some coefficient of friction mu, and this object is on a ground, this plank is on a ground which is smooth. Now I am asking you like the question, okay, the first question that I'm asking you is, find the distance covered by the block with respect to plank before it is coming to rest related to the plank. What is the question that I'm asking, sir? The question is, find the distance covered by this block with respect to plank before it is coming to rest with respect to the plank. This can also be solved in different ways. One is a lengthy way, another one is like, okay, so like shortcut by using some concepts. Again, give me an idea, like what ideas you're getting. This question you have seen in tomorrow's advanced paper. What? Again, I'm telling you can just tell me what ideas you're getting. That's it simply. What can be done if this exam, if you see in tomorrow's like exam directly?
By velocity of center of mass.
By velocity of center of mass, what will you do? Actually,
The
I want to
velocity
find
will remain constant, so we can find the distance.
velocity remains constant. That's fine because net force is 0. Velocity of center of mass will always remains fine. That's fine. But from there, how can I find distance? That I didn't understand. Cannot find distance. We cannot find the distance actually. How to solve? Anyone? See, actually, by taking, obviously, initially slipping will be there. Acceleration on this one is fixed, and acceleration on this one is also fixed. So, can you tell me what is the acceleration of this one? Acceleration of this one.
Mu G.
Mu G, and the other block?
Mu small mg by capital M.
Mu mg by capital M. Then tell me, can you find the relative acceleration or not?
Yes.
See, acceleration of this one is mu G, correct? And acceleration of this one is what, sir? Mu mg by capital M. Then that means you know the acceleration of this one, you know the acceleration of this one. Both will be in same direction actually, because the force. No, my bad. Force on this one, force of friction on this one, it will be in what direction? On this one, because of this, it will be going right side. F will be left side. On this one, it will be in what direction? Right side. So therefore, acceleration of this one will be relative acceleration. How much will be there? Because of this acceleration will be left side. Because of this acceleration will be right side. That means relative acceleration of block with respect to this, if I find, how much you will be getting? Minus already initially mu G is there. Now minus mu mg by capital M. Is it clear? This is the relative acceleration of block with respect to Planck. Understood? Understood, right?
Yes.
Now tell me, this is a constant or variable? Constant. Right? And when the they're asking us to find the relative displacement of this with respect to this. Okay. With respect to this means basically relative displacement only they're asking. When it is coming to rest, right? That means initially V relative is how much? That I am calling it as U relative, initial velocity. U relative, how much I am calling? 0. V relative, how much? Not my bad. U relative is not 0. Initial relative velocity is what? V naught. Relative velocity finally is how much, sir? 0. And I know the relative acceleration also. This is nothing but my relative acceleration. Now, which formula I'll use, sir? V square minus U square equal to 2as. Done within one step. Is it clear? I told you just now, relative things also, I'll be taking it like on parameter only. V square, 0 square, minus U square. Initial velocity relative square is V naught square. 2 into acceleration, minus sign is there, no? Minus of mu G plus mu mg by capital M into displacement S. So minus will get cancelled. Okay, actually, this is not minus, okay? This is minus into. So this minus will get cancelled. So S equal to V naught square by 2 mu G of 1 plus small m by capital M. Is it clear?
Yes, sir.
Understood, no? Actually, without this relative concept also you can solve. Sir, how would have how we would have solved this question without relative velocity or relative acceleration concept? How to solve means, like what is the final velocity of this one. Okay, all these are like important concepts. Okay, these are the things which you will be useful like when you're tackling advanced questions. Okay, not only this, like that many concepts will be there. You need to just like, as I said, there is no end. Okay, you need to keep on learning like concepts. Okay, so here, as when both will move together. So as you said, velocity of center of mass will remains constant. mv naught must be equal to, now both will move together. Okay, final momentum m plus m into what, sir? V. That means final velocity is how much? mv naught by m plus m. This is the final velocity. Correct? Correct, no?
Yes.
Now, see here. You know the final velocity of the block, initial velocity of the block, and you know the acceleration of the block. Then can I find displacement of block with respect to ground or not? All these things you need to understand with respect to ground only. This V, whatever the velocity V we got, and V naught, these are with respect to ground. So when I use V square minus U square equal to 2AS, I'm going to get displacement of block with respect to what, sir? Displacement of block with respect to ground.
Sir,
It's
but you
similar.
have asked that find distance when small block will come to rest. So
Find
final
the
speed, you have asked that find the distance when smaller block will come to rest.
not distance. Find the relative distance traveled by small m before it comes to like at rest relative to the block m.
Okay. Yes.
That's the question. Okay.
Yes.
Now we have found displacement of this small m block. Similarly, you can find displacement of the capital M block also, right? By again using V square minus U square equal to S, then both will travel right side. Then I'll just subtract the displacement of those two, and then also I'll get the final answer as this one. Understood? Is that clear?
Sir, I didn't understand second one.
Second one, no. See, second one, initially what initial velocity of small m block is what? V naught. Final velocity is how much, sir? Common velocity V. Correct? This
Yes.
V. Both will move with this common velocity. Now you know initial final velocity, initial velocity. So I'll use V square minus U square equal to 2AS. Then I'll get displacement of small block. Displacement of block with respect to ground. Then when you take Planck, for Planck also tell me you know the final velocity and initial velocity or not. Initial velocity of Planck is 0. Final velocity of Planck is how much? V. So again I'll use V square minus U square equal to 2AS. Then what displacement I'll get? Displacement of Planck with respect to ground. I got the distance covered by the block. I got displacement covered by the block, displacement covered by the Planck. Relative displacement means I'll just subtract.
Yes.
That's what I'm asking. No, relative displacement of block with respect to Planck. So I need to subtract those two to get the answer.
Yes.
Clear?
Yes.
Understood? Yeah, okay. So then as you guys asked for the constraint motion, I'll take up some 2 to 3 good constraint motion questions. So let us solve. Actually, one more thing I want to ask. I don't know why they kept alternative day. So you guys if you want daily classes?
Yes.
Huh? So if I take class daily, can you guys attend?
Yes, sir.
Okay, because no, I was unable to cover many concepts if every alternative day is there. So I'll just ask them. If they tell okay, it's okay. If they're not telling okay, then I'll take on my Zoom session separately. Okay. So not here. I'll be just sending you the link in the group. Then you can just join. I'll take the class. Yeah.
Sir,
We'll
then
see.
will you take of shorter duration?
Short duration. 1 hour or 1.5 hours. I didn't understand.
1 hour or 1.5 hour?
Yeah, sure. If I take daily, for sure I'll take 1 or 1.5 hour. If I take a alternative day, I'll take for 2 hours. See, this is an inclined plane. Inclined plane is given or wedge is given. Okay, which is like free to move. There is no friction anywhere. Okay, this is capital M and this is small m. Now the question is, Find the acceleration of wedge. Find the acceleration of wedge. Actually, the wedge is like what? Tell me the wedge got constrained or not? Wedge can move only along what direction? Only in what direction wedge can move?
Horizontal direction.
Horizontal. So that's like wedge is constrained. And this can move only along the surface. But actually, can anyone tell me what is the trajectory or the path that will be followed by the small m?
It will be like a straight line.
Actually, it will be like a very weird. It will be something like curve like this. Completely weird. Why, sir? Why? Because if it is at rest, then you guys can tell it will simply go like this. But it's moving, no? Wedge is moving. So it's going down at the same time it's going back. Actually, it won't be traveling some straight path. It will be actually going some curved path. Some random shape it will follow. Understood? Sir, but
Sir,
what I can tell for sure is with respect to this block, this is constrained.
sir,
Understood what I'm telling? With respect to this block, that means a man
sir,
standing. Huh?
if small m is equals to capital M, then it might be the straight line.
If small m equal to,
Capital M.
then also shape will be some random, no? Center of mass won't change. Center of mass position should be there. Okay. Then also I guess it will be like some curve, but some like what I can tell, maybe some finite like what definite shape you might get. But then also it's not a straight line. When it will be straight line, when it is at rest only, it is going to be a straight line.
No, I am talking about a vertical line. If small m is equals to
Vertic-
capital M.
Vertically,
Vertical line.
what vertical line? This vertical line.
Hmm.
No, you are telling that this block will come vertically down and both the mass are same.
Yes.
Why?
I just thought.
No, they won't come. See, that's why. See, when you want to discuss with respect to ground, it will be difficult for us to analyze. Okay, in some special case that might happen, that we need to check. But one thing you can tell for sure, what you can tell for sure is, with respect to this block, tell me this block will be going along the wedge or not?
Yes, sir.
That we can tell for sure. That means the velocity of block with respect to the wedge is downward. That I'm taking it as some C. Like take it as A, whatever it is, A. But that A is not with respect to ground, understand? Is that A with respect to ground? No. That is with respect to wedge. Now wedge is constrained or not? Wedge can move in what direction? Wedge can move in what direction?
Horizontal.
Only left side. B. Now, see. Now, if I want acceleration of this with respect to ground, what I should add? I should add the acceleration due to wedge or not? That means actually now the acceleration of wedge will be what, sir? A resultant of these two accelerations. Is it clear?
Yes, sir.
This A is what? Don't get confused. This A is what? Tell me. What is
Acceleration along which
acceleration of block with respect to wedge? And B is what, sir?
acceleration of which.
Wedge with respect to ground. So if you want
Yeah.
acceleration of block with respect to ground, I'll be just adding this B. That's it. Constant is done. Okay. Now, sir, what should be done? You just draw the free body diagram. Sir, what is free body diagram? This is mg. And so obviously like here n will be there. You resolve the accelerations also along the like what inclined plane and perpendicular to the inclined plane. Sir, B, if you resolve that along the direction, what you're going to get? When you resolve the B, if this is theta, this will also be theta. No, you'll get B cos theta like this. And perpendicular to this, what will you get? B sin theta. Now, in downward direction, what is the force that is there? Mg sin theta will be there. So mg sin theta will be equal to mass times of acceleration is what, sir? A minus B cos theta. Is this clear? Net force towards and like downward along the inclined plane equal to mass into acceleration. Acceleration of this with respect to ground in this direction will be A minus B cos theta. Fine, no?
Yes.
And what about acceleration of the other one? Like, sorry, not other one, in other direction. In other direction, what it will be? Perpendicular, no. See, it's going in on this direction, obviously acceleration. That means mg cos theta minus n will be equal to what, sir? mb sin theta. Is it fine? Correct, no? Wedge accelerations, I just, block acceleration, I just resolved along the inclined plane and perpendicular to the inclined plane. And forces also I resolved along the inclined plane and perpendicular to inclined plane. Can you guys tell me total how many unknowns are there here? 3. What are those 3? Can you tell?
A and B.
A and B, and one more unknown is there.
Normal.
Normal force. So we need how many equations? 3 equations. The other equations are from where we can get, means normal force on the wedge, it will be in what direction? Perpendicular downward, action reaction pair. On this it is upward, on this it is downward. Now this force, okay, on this force only I need horizontal component of this force, no? Sir, what will be that component? If this is theta, this will be 90 minus theta, so this will be theta. So what component you are going to get, sir? Normal force. N sin theta component you are going to get. So n sin theta will be equal to what? N sin theta will be equal to n sin theta will be equal to what?
MB, capital MB.
MB. So that's it. So 3 equations, 3 variables. Solving part I am not telling. So if you just solve these 3, you will be getting the answer. Clear?
Yes.
Understood, no? Now I will give one question. Okay, you guys tell me what will be the answer. It's a simple question but tricky, okay? So always I told you, okay. So advanced question means don't think that all the questions will be like tough. Ensure that your basics are strong and you just need to approach for the questions. So if this angle is theta, I'm giving a question. There's a wedge which is free to move on a ground. There's a wedge which is free to move on the ground. Here a pulley is there attached to the wedge, and here also there is some pulley here. Now let's say I'm applying, there's a thread like this tied in this way. On top of the ground there is another block of, let's say, small m, capital M, and here I'm applying force F. The question is, find the acceleration of the wedge and find the acceleration of the block. Situation you understood, right? Both, there are 2 pulleys here. There's a thread from here to here like this. So this is small m, this is capital M. So you guys need to find what is the acceleration of both the blocks, block and wedge. What is the acceleration of small block? Can you tell? Block. Acceleration of small block.
F by M.
F by M. Correct. Good. Simple, no? It's only one force is there, that force only horizontal direction. So, tension along a string will remain same completely. So, F by M will be the answer. What about acceleration of wedge? Acceleration of wedge. Acceleration of wedge.
0.
0. Yeah, it's 0. Sir, why it is 0? See here. If you draw free body diagram of wedge, here F will be there. Here right side F will be there. Here F will be there. Here F will be there. These are the free body diagram, no? And see, this F and this F will get cancelled. This right side F and left side F will get cancelled. Here there is no constraint. This wedge will not move because net force acting on the wedge will be 0. Because this, whatever the forces that are acting on pulley, no, you just consider those are the forces acting on the wedge because the pulley is a part of what, sir? Wedge. So right side F, left side F, both will get cancelled. And this F both will get cancelled. Net force on the pulley is 0. Sorry, the block wedge is 0. That's why the force will also be what, sir? 0. Clear, right? Understood?
Yes, sir.
So one more question. PVK or sir. Second. See here, this is one more like good question. So here they're telling that acceleration. Okay, so there's a 4 meter long rod. They've given velocity of A is 4 meter per second to the left, and acceleration of A is 5 meter per second square towards right. And when the angle theta, okay, when the angle theta equal to 30 degrees, at that when at what instance are when theta equal to 30 degrees, they're asking us to find the angular velocity of this like rod. They're asking us to find angular velocity of the rod. Okay. So I'm asking the first question. The question is, so you guys tell me when this acceleration is sorry, velocity is left side, why acceleration is right side? Can you tell? Why acceleration is right side?
Because of friction.
Because it will moving left side, friction will be right side. That's why acceleration will be right side. Okay. Yeah. Now tell me how to find the angular velocity. How could I find the angular velocity here?
By finding axis of rotation and distance.
Yeah, instantaneous axis of rotation. Okay, sir, what is instantaneous axis of rotation? How to find? How to find?
Perpendicular to velocity.
Any two velocities you have to take point. Okay, any two velocities of like the rigid body and draw perpendiculars to both the velocities wherever they are meeting. That is what, sir? That is the instantaneous axis of rotation. And what is the specialty of the instantaneous axis of rotation? What is the specialty of the instantaneous axis of rotation?
It always changes position.
No, no, no. That's fine. It will change the position that's there. What is the specialty of that? The specialty of that point is at that instant, the complete body will be behaving as if it is rotating about that point. That's why it's called instantaneous axis of rotation. At that instant, okay. So that about that point, the whole body is going to what, sir? Rotate. So how to find this one? See, this is given already VA. Let me take this velocity to be what, sir? VB. So this angle already they gave, no? So first of all, let me draw the perpendicular from here to here. It will be going somewhere over here, and perpendicular to this, it will meet somewhere over here. Let's say it's meeting over here. Okay. Now, sir, how to find that angle means, let's say I'm drawing here. Let's say I'm drawing the perpendicular here. This is 30. Then what is the remaining angle? This angle is 60 degrees. Fine. What about this angle? Can you tell? If this is 30, obviously this will also be 30.
15.
This will be 15. Then this is 15, 15, 30, 55. This will be how much? 45. And this is
45.
also 45. So when this length is 4, this length is 4 opposite to 90. Opposite to 90. This length will be 2 meters. And this length will be what, sir? 2 root 3. When this is 2 root 3, because this is also 45 degrees. So opposite to 45, 2 root 3, this will also be 2 root 3. That means what is the total distance from here to this perpendicular, sir?
2
What is
plus
the
2
total
root
distance?
3.
2 plus 2 root 3. So therefore, omega is nothing but what, sir? Omega is nothing but simply VA by V equal to R omega, no? R perpendicular we have to take. And this is obviously R perpendicular only. So therefore, answer is what, sir? VA by 2 plus 2 root 3 will be the answer. This is the omega. Clear?
Sir, we can also find omega by V perpendicular relative by R to the rod.
Understand. V perpendicular. But that will be little lengthy, no? That way also you can find. Whatever you said, that's also correct. So what he is telling, that also I'll explain. That is also an like very important thing. Okay. See here. But that will be lengthy. That you can only see. So this VA already I got. Now VA as I got. Constraint here I'll be using to find VB. To find VB, I need to find what, sir? Like what? I guess like what you assume, no. I guess it's like seeming to be easy, because I guess you just resolve this velocity perpendicular to this one, and you're imagining that you would have imagined that divided by this length. That is what you have assumed, thought.
No. We have also resolved. We will also resolve that VB, and
B,
then
yeah.
we will add
Then you
those.
have, that's correct. But it will be lengthy, no? Related to this one, tell me that will be lengthy or not? You'll get the answer. Okay, for sure you'll get the answer, but it will be relatively lengthy. Okay. So this component will be what, sir? VA cos 30, and this will be what, sir? VA sin 30. And this will be like what? VB cos 15, and this will be what, sir? VB sin 15. What is constraint? Constraint, rod constraint. What is rod constraint? Velocities along the rod must remain same. Velocities along the rod must remain same means VB cos 15 must be equal to what? VA cos 30. So this is one constraint which you got relation between VA and VB. Once you get VB, so as he said, okay, omega can also be written as what, sir? V relative by the perpendicular distance. Perpendicular distance. What is V relative? Can you guys tell? VA sin 30 minus VB sin 15 by perpendicular distance is 4. When you solve it again, you will be getting the same answer.
Sir, VA sin 30 plus VB sin 50.
My bad. Yeah, plus. Why? Because both are in what, sir? Relative velocity you need to get, no? So this is C upward and this is downward. So relative velocity, it will be like what, sir? Both are in opposite direction. It will be added. So you need to keep plus by 4. And this way also, you're going to get the same answer, whatever we got here. Okay. But acceleration I'm leaving for you as a homework. Okay. It's not that easy. It's not like simple. Okay. So I want you to try that. Okay. Why that won't be simple? No, you only tell me. Okay, you might be like thinking like that. Sir, what is the difference, sir? Like here, no, the acceleration, like what? This is there, sir. Like this A acceleration of A is given. This is given. Okay, and this way I'll same way I'll do. I'll be getting the again R alpha angular acceleration. I'll find and I'll solve. But here you need to understand that because of this velocity, okay, because of this is like rotating in circular motion, along with tangential accelerations, there can also be what acceleration? Centripetal acceleration. Okay, so it's not like velocity is different and like accelerations are different. Okay, so if you think that the same way I'll solve and I'll get the answer, okay, you won't get this as the answer. So that I'm leaving as homework for you. You just try it. Okay, if you're not getting it, I'll explain the next class. That I am leaving as a homework for you. Okay. So this is a like solution for that. So it will be little lengthy actually. Okay. So that anyway I'm leaving as homework for you. Just solve it. That's actually the advanced question. Okay. It's like very, it's a good question, very good question. So you guys try it. Okay. And one more final question I'll take constraint and we'll end it. Another question, no? As I told you, next class we'll be doing current electricity, and tomorrow I'll send you like just like however I send. First of all, I'll send you the solution for whatever the questions that I've sent. Along with that, also I'll send you. Okay, also I'll send you solutions of this one. Also I'll send you the current electricity questions. You try all those questions. Okay, so tell me, you want me to send the solutions for current electricity or no? You want to try it and like get the solutions later or like immediately on the solutions? What you prefer? No necessarily. Okay, I'll just send the solutions also. Okay, so both solutions and sheet. You can do like whatever you want. So tell me like what is the idea? So now the wedge is also free to move. Now tell me what I should do. They are asking us to find acceleration of relative acceleration of 5m. Oh, sorry, the small m with respect to the 5m. This is again constant question. What should be done? Tell me. The wedge is constant or not? First of all, tell me. Wedge is constant or not?
Yes.
So wedge will be moving in what direction?
Horizontal.
Horizontal direction. So let us take that acceleration of this is what? Left side, some A. Now this is, but now with respect to this, tell me, now if I stop, if I'm standing on the wedge, the 2 should go simply down and this M should go simply left side. Is that correct? When the wedge is fixed, I'm talking. When the wedge is fixed, it is very easy for me. Sir, what is that thing? It will go downward, let's say with acceleration B, and it will go left side with what acceleration, sir? B. But what are these B and B? Can you tell? What are these B and
Acceleration
B?
with respect to which?
Acceleration with respect to which? But we need acceleration with respect to what, sir? Ground. So that means I need to add this. So acceleration of this will become what, sir? B plus A, and acceleration of this will become what, sir? Resultant of this B and A. Okay. Now, if you see here total how many unknowns you're going to get means here I'll introduce one more force. What is that one more force? Can you tell? What's the one more force I'm going to introduce? Normal force I'm going to introduce, and also tensions I'm going to introduce. Total how many unknowns are there? Tell me.
4.
4. So how many equations we need?
4.
So how will you get 4 equations? Tell me. Solving part anyway will do. How will you get 4 equations?
First one from 2m in force, resolving force in vertical direction.
On net force in vertical
Net
direction
force
T.
in-
So that T equal to m into B. That you will get one equation. and like equation horizontal direction, that you'll get two equations. Actually, with 2m you will get two equations, and with m you will get one equation, and with 5m you will get one equation. So four equations, four variables. Okay, you just solve and you'll be getting the answer. So whenever you're getting confused of taking acceleration, what you should do, sir? Always stop that block with respect to that wedge. You give the acceleration of other one, that will become easy. Then just add the vector, like vector addition you have to do, vector sum of this acceleration to all other things. Clear? Understood, right?
Yes,
Yeah,
sir.
one more
Sir,
thing,
with respect to which acceleration on block 2m and m will be on right side.
with respect to wedge, acceleration of,
Acceleration on 2m and n will be on right side.
I didn't understand. With respect to wedge, acceleration on m and no, this
2m.
is not pseudo force. This is not pseudo force. I'm not adding pseudo force. Acceleration of wedge with respect to acceleration of block with respect to wedge is B. If I want with respect to ground, what you have to do? See here. Acceleration of block with respect to wedge is nothing but acceleration of block with respect to ground minus acceleration of wedge with respect to ground. If you want acceleration of block with respect to ground, what I should do? Tell me. This is not pseudo force, okay? Acceleration of block with respect to wedge plus acceleration of wedge with respect to ground. You just need to add that vector.
Yes, yes.
Clear? No, pseudo force is
Yes.
different, relative velocity is different. Okay?
Yes.
Uh, so have you checked this one marks? How many marks you got, Viraj?
Sir, I didn't do it like a test.
Not that. Mains, second attempt.
232.
232. Nice. First attempt, you only got a 99.8.
Yes.
Next, Varad,
Sir, I didn't check marks.
Shivik, how much you got?
What, sir?
No, one more student. Shivik, how many marks you got? Shivik, no. Yes, he is unmuted. Yeah. Okay, then. So I'll be sending you the solution for the previous sheet and current electricity questions I'll send. So that we'll be doing on Saturday. Okay. Yeah, and you guys are not didn't send me like any question, like any questions, any doubts you didn't send me. Only like you practiced to the questions that I'm sending. That's it. You haven't practiced any other questions. Viraj and Varad.
Sir, I am practicing PYQ papers.
Okay, from that
Advanced
also, if
papers.
you have doubts, no, you can just ask me. See, like tomorrow you don't have class, no, but you have my number, right? So like you
Yes.
have any doubts, you can send me. Either I'll send you some like voice message, or like something. I'll send you the solution. Okay. Even if you don't have class, no, you guys can like take help from me. Okay. You can message me anytime and you can call me also. Okay.
Yes.
Yes.
So is
Okay.
tomorrow,
Okay.
there is tomorrow class. Is there a class
Tomorrow,
tomorrow?
um, it's up to you. You want, if you both of you guys want, I'll take. Otherwise, I won't take. It's up to you. If you want on a particular topic, I'll just take for 1 hour. That's fine, no? 1 hour I'll take. Whatever the topic you want, you just tell me. What topic you want. Current electricity, when now, if like, okay, current electricity only we'll do tomorrow then. Time I will update you. Where can I update the time?
On the WhatsApp group.
WhatsApp
Sir,
group.
we will do all chapters, means almost chapters of advanced practice.
Okay, then like around 40 days are there, right? That
Yes.
means like every chapter we can do for 2 days. So 2 days each chapter. Okay, we'll do different questions and different models. We'll try to cover all the things. Okay. So tomorrow and day after tomorrow, we'll do current electricity then. Okay. Yeah.
Yes.
Okay. So I'll send you the link tomorrow. You guys can join. Okay. So we'll discuss current electricity.
Sir, what should I solve? US-ended question or PYQ papers? Because I
Either,
don't much time.
nah,
I can
that's
solve
good.
any
Like,
one. One
nah,
means only one of them.
either you do PYQs or the questions that I've sent. Anything. It's about learning the concepts. Okay.
Yes,
Whatever you do, and for this one, you do anything, but try to learn new concepts. Okay. Today you must have learned some 3-4 concepts. Like that every day in every subject, you should learn some new concepts, new techniques, new concepts. How from where you can solve from doing good questions that might be PYQs or like whatever I'm sending that also contains good collection. Okay, almost all the questions are like good, like top questions. Okay, that's the material that is given for like our institute like top, so you can solve that or like PYQ anything. Just learning the concept is the key thing and understanding it properly so that next time that concept comes, you should be relating that and you should be able to apply that. Okay.
yes,
Okay, I'll update the time tomorrow. You guys can join and we'll do current electricity tomorrow.
yes.
Okay. Bye. Good night.
Good morning.